Hey everybody. So today we'll be talking about linear equations. So equations that help us graph or evaluate or analyze lines. So this should hopefully be fairly review material, but if not, pay attention to the video. Pick up some things about the different forms of equations that describe lines and use that to help you with the worksheet today. So first thing we'll talk about is slope-intercept form. Y equals mx plus b, where m represents the slope and b is the y-intercept. This is probably the most common equation that you've seen thus far. Now we will use it a lot, but we'll also be mixing in point slope form and standard form as well. So if you look at some guided practice, when an equation is in slope-intercept form, it's very easy to analyze some of the key features like slope and y-intercept. So if I rewrite this in a slope-intercept form, all I would have to do is divide by 2. Slope-intercept form is really just having the y variable isolated by itself, right, on one side of the equation. So we want y by itself. Now, from here, I can actually visually see the slope and the y-intercept in the equation. -3 is my slope, and 8 is naturally my y-intercept. Now we look at some other examples, like generating an equation from the line. We have the slope of -2 and the y-intercept is 3. Well, if we want to write an equation, that'd be y equals -2x plus 3. Again, pause the video at any time to try to do some of these problems on your own, then hit play to check it with my work. If I have information like this, passes through -3, 4, and 0, -4. Well, this is my y-intercept. But I don't have the slope from this information yet. To find the slope, I might want to employ the slope formula that we reviewed the other day. We'll set this up. -4 minus 4, that's the change in y, over the change in x, 0 minus -3. Simplifying, we get -8 over 3. So our slope is -8/3. And then we could write the equation of the line. Lastly, we have an equation that we can then rewrite and then we'll actually graph, right? So we have 15x minus 3y equals 6. Again, when we're solving to get this in slope-intercept form, our ultimate goal is to get the y variable isolated by itself. The first thing I did, and I didn't write it out, but I just subtracted 15x from each side of the equation. Next, we're going to divide by -3. When we divide by -3, make sure everything on the right-hand side gets divided by -3. We get 5x minus 2. Therefore, we can make a graph starting off at -2, right, our y-intercept. Then we use our slope. We're going to count up 5, right 1, because that's 5 over 1, even though we don't have the 1 written out. 1, 2, 3, 4, 5, right 1. And then we can graph the line accordingly. Adding arrows on each end because obviously the line continues to go on for infinity. So that's a review of slope-intercept form. Now, another form that we're going to be used to seeing is point-slope form. Point-slope form doesn't have the y-intercept for us, but it describes other features of the line. It describes our slope and a point on that line. Now, slope-intercept form happens to be a point, that's the y-intercept. Point-slope form, that point can be any point, does not necessarily need to be the y-intercept. So, in my little blur here, notice, but so it's useful to have it when you don't know the y-intercept, right? So we want to write an equation for the line and then find the y-intercept. So first, my example has a slope of -1/5 and contains the point 15, -5. So the way I write this equation is y minus the y-coordinate, which is -5. We'll change that double negative to a positive in a second. Equals the slope, and it's x minus the x-coordinate. And there you go. That's point-slope form. That's the equation of a line in point-slope form. Now, if we want to find the y-intercept, right? We want to find the y-intercept. There's actually a couple different ways that we can do that, right? We can rewrite this equation to be y equals form. So that's one way we can do it. So let's try that. Let's rewrite this to be y equals format. First, I'm just going to change that to a plus 5, just to demonstrate that double negative is a positive. When we solve this, we're going to do this in 2 steps. First, we'll distribute 1/5 on this side, and we'll minus 5 on the left-hand side. Y plus 5 equals negative 1/5 x plus, because negative times negative makes a positive, 3. We're going to minus 5, minus 5. We have y equals negative 1/5 x minus 2. Therefore, my y-intercept is negative 2. On this side, we have contains the points 1, negative 4, and 5, 2. So I don't know the slope at all, but I have 2 points I can use. So first, let's find the slope. So using our slope formula, I have the change in y over the change in x. When we say change, that usually indicates subtraction, because we're trying to find the change, or how much did it grow or decrease by. Just like when you find change at a grocery store, you subtract the amount the bill from the amount you paid. So now we're going to subtract. We end up adding because it was double negative, and we get 6 over 4, which can be simplified to be 3 over 2. So we're going to use that reduced fraction. My equation, therefore, is y minus a y point. Now, I can use either one of these points. Doesn't matter. Right? Doesn't matter. So I'll check that first one. I changed it to a plus because minus and negative 4 is the positive. Equals the slope, x minus the x coordinate. Right? And that's in point slope form. If you want to figure out the y-intercept, I'll leave that for you. So you can go back and determine what that y-intercept may be. Here's our last portion of the notes today. Determine the x and y-intercept. So what is the x-intercept? It's which value is at 0 at any x-intercept, the x or the y. Think about that for a second. All right, your 1 second's up. So which value is 0 at any x-intercept, x or y? Well, the y value is 0. Therefore, to find the x-intercept of a line, substitute 0 for y in the equation and solve for x. Obviously, the y value has to be 0 for an x-intercept. An x-intercept implies that the point is on the x-axis. Well, if a point is located on the x-axis, therefore the y value must be 0. Likewise, it's the reverse for the y-intercept. The x value has a value of 0, and we'd be solving for y. And the same thing, a y-intercept is on the y-axis. So picture the y-axis in your head, the vertical axis. If a point is on that y-axis, the x-coordinate must be 0. So if we wanted to determine the x and y-intercepts from an equation in standard form, or general form, there's something that's called this as well, we can just do a little alternative substitution. So let's say I plug in a 0 for x. So one little trick that I like to do is I just like to cover it up. If I plug in a 0 for x, you can just cover that right up, and we can solve for y. So we can solve for y. Now, if you want to write this out, we can obviously put in a 0 and show this algebraically as well. But you could just literally just cover it up, because 2 times 0 is going to be 0 anyway. So this is obviously going to turn into a 0, so it's just going to disappear. 5y equals 10, divide both sides by 5, y equals 2. That's my y-intercept. This is my y-intercept. To figure out my x-intercept, I'm going to basically just cover up this portion, the y portion. Five times 0 is just 0. That's why I'm saying you can just cover up. Like, you don't even need to show me that step. You can just cross it out if you want. 2x equals 10. Therefore, x must equal 5. Dividing both sides by 2. This is my x-intercept. So, from this information, I actually have 2 coordinates that I can use to graph. We have the coordinates 0, 2 and 5, 0. I can use this if I was doing a graph. I can actually then graph this on graph paper and go from there. Alright guys, hopefully these notes helped clarify or help you guys brush off the dust from the memories of linear equations. Good luck on the practice today. Let me know if you need any help in the comments on Google Classroom, in the email, or if you guys need even more direct help, we can set up a Zoom for one-on-one or a group of you guys. Alright, good luck.